Hi everyone, welcome back. Today we are going to discuss the remaining topic of ionization enthalpy from classification of elements and periodicity in properties. Okay, let us start. The first ionization enthalpy of boron, that is Z is equal to 5, is slightly less than that of the beryllium, that is Z is equal to 4, even though the former has a greater nuclear charge. Boron, Z is equal to 5. Beryllium, that is Z is equal to 4. There lies in the same period. So we know that if we move across from left to right in a period, the ionization enthalpy increases. But in this case, the ionization enthalpy decreases. Boron, the ionization enthalpy of boron is slightly less than that of the beryllium. Okay, what is the reason? When we consider the same principal quantum level, an s electron is attracted to the nucleus more than a p electron. In beryllium, the electron removed during the ionization is an s electron, whereas the electron removed during the ionization of a boron is a p electron. The penetration of a 2s electron to the nucleus is more than that of a 2p electron. Hence, the 2p electron of the boron is more shielded from the nucleus by the inner core of electrons than the 2s electrons of beryllium. Therefore, it is easier to remove the 2p electrons from the boron, okay, than to the removal of 2s electrons from the beryllium. Okay guys, that is very important topic. Please listen here. I will explain once again. Boron. In the case of boron, Z is equal to 5. So we know the electronic configuration 1s2, 2s2, 2p1. But in the case of beryllium, Z is equal to 4. Here 1s2, 2s2. Okay. If we consider the principal quantum level, an s electron is attracted to the nucleus more than a p electrons. Okay, in beryllium, the electron removed during the ionization is an s electron. Electron removed from the 2s electron. Electron removed from the 2s orbital. But in the case of boron, the electron removed from the 2p orbital. 2s electron is penetrates more to the nucleus than 2p electrons. Okay. In addition to that, 2p electrons of the boron are more shielded from the nucleus by the inner core of 2s electrons. Okay. Therefore, it is easier to remove the electron from 2p. So, it is easier to remove the electron from 2p than 2s of the beryllium. So, ionization enthalpy is less in boron than beryllium. In the case of boron, its atomic number Z is equal to 5. So, its electronic configuration 1s2, 2s2, 2p1. In the case of beryllium, Z is equal to 4. The electronic configuration 1s2, 2s2. Here we should remove the electron from 2p. But here, in the case of beryllium, we have to remove the electron from 2s. The penetration of the 2s orbital, 2s electrons to the nucleus is more than that of 2p electrons. In addition to this, the 2p electrons of the boron is more shielded from the nucleus by the 2s electrons. Therefore, it is easy to remove the 2p electrons from the boron than 2s electrons from the beryllium. So, the ionization enthalpy is less in the case of boron than that of beryllium. Okay, very important, study clearly. Another anomalous is the smaller first ionization enthalpy of oxygen compared to nitrogen. This arises because in the case of nitrogen atom, 3 2p electrons are reside in different atomic orbitals. Whereas in the oxygen atom, 2 of the 4 2p electrons must occupy the same 2p orbital, resulting in an increased electron-electron repulsion. Consequently, it is easier to remove the fourth 2p electrons from oxygen than it is to remove one of the 3 2p electrons from the nitrogen. In the case of oxygen and nitrogen, its atomic number is 7. So its electronic configuration 1s2, 2s2, 2p3. 2p3, that we know p has 3 orbitals. These 3 electrons occupies in 3 different orbitals. In the nitrogen atom, 3 2p electrons occupy different atomic orbitals according to Hund's rule, where in the case of oxygen its atomic number is 8. So 1s2, 2s2, 2p4. And the 2p4 according to Hund's rule of maximum multiplicity, 2 of the 2 4 2p electrons, 2 of the 4 2p electrons must occupy the same 2p orbitals, resulting in increased repulsion, electron-electron repulsion. Consequently, it is easier to remove the 4th electron from the oxygen than it is to remove one of the 3 2p electrons from the nitrogen. So ionization enthalpy is greater in the case of nitrogen than oxygen. Understood? You have to write in your own words. In the case of nitrogen, its atomic number is 7. Its electronic configuration 1s2, 2s2, 2p3. The 3 2p orbitals, 3 2p electrons reside in different atomic orbitals according to Hund's rule of maximum multiplicity. But in the case of oxygen, its atomic number is 8 and electronic configuration 1s2, 2s2, 2p4. Here the 4 electrons are. Among the 4 electrons, 2 electrons are occupying in the same orbital. Okay. Therefore, an increased electron repulsion among these 2 electrons. So it is easier to remove the 4th 2p electrons from oxygen. Okay, therefore the ionization enthalpy of oxygen is less than that of nitrogen. Okay guys, it is very important. Study clearly. Okay. Okay, study up to here. The remaining topic we will take in the next class. Bye.